In the beginning of our third practical, we are going to see the histogram stretching. So histogram stretching is the method that used in Erdas imaging to increase the contrast of the satellite image. So first of all, let's open our data of the third exercise. Go to the folder and data. Then get the minute area band 4 image. So this band 4 image is displaying near infrared band of the ETM plus sensor, and to see the data of the histogram, what we can do is we can go to the metadata of the image under the home menu. And in metadata you will be able to see the major details of the image, minimum values and the maximum values, then mean values, median, mode and standard deviation, likewise the factors. So in here, if you move into the histogram tab, and you will be able to see the histogram of this satellite image. So this x-axis is representing the bits of the satellite image 0 to 256, and the y-axis is representing the number of pixels. So if you move your cursor within this histogram, you will be able to see these points are representing the minimum value, then the maximum value, as well as the mean value of the satellite image. So generally in Erdas imaging, this histogram is created by using the sample image. So rather than taking the whole population, we can check how these values are calculating by using the samples. To see that, we can get this sigma icon in the metadata, and here you will be able to see a window which is showing pyramid layers, so statistic generation options, and these skip factors are showing the pixels that they are containing when they are doing these calculations. So if we change the max skip factor of the x value into about 35, as well as the max skip factor of y value into 35, and then if you click on OK, give yes to here, then you will be able to see that the shape of the satellite image histogram has changed like this, because when we are changing the skip factor, so the meaning is they are calculating these statistics by using and skipping 35 pixels. So that's the meaning, and you will be able to see that again. So these maximum value and the minimum value also changed now, as well as the mean value already changed. And if you want to go to the first one again, what we can do is just click on this sigma icon, and then now you will be able to see that the maximum skip factor is x for 1 now, and as well as the max skip factor to y is 1 now. So then just click OK, and you will be able to see the shape of the histogram has changed, as well as the minimum and maximum values also change. So this is one way that we can see this histogram. And another thing is, generally when we are adding a satellite image to the Erdas imaging, automatically the contrast of the image has increased by the software. To see that, what we can do is we can go to the panchromatic under the raster in here. Then under the panchromatic menu there is a option which is known as adjust radiometry. Click on that, and here you will be able to see the option which is known as breakpoints. Click on that breakpoints. So in here you will be able to see a breakpoint editor window of our satellite image, and it is displaying our original satellite image with gray color and the stretched image with yellow color. So in here, to increase the contrast of our image, the Erdas imagine automatically stretch this histogram of our satellite image. To see the stretching, what we can do is we can click on this LUT icon in this breakpoint window, breakpoint editor window. Then here you will be able to see the maximum and minimum values. So the minimum value of X 49 has stretched up to 0. So here the 49 value has stretched up to 0, as well as the maximum value 142 in here is stretched up to 255, or to this end. Then due to this reason, our satellite image, the contrast of the satellite image has increased. But remember that these values are not changing the DN values, only to increase the visual quality they are increasing this grayscale values. So by clicking on this LUT icon, we can change these values. Let's change and see. So I'm going to put here Y value same as the X value 49, and here again 142. Then now you will be able to see that the both original histogram as well as the stretch histogram is now equal. And then just close this one, and to see what happened when the stretching was minimized by like this. So what we can do is we can just click on this red color lightning mark. So here you will be able to see that now the stretching is minimized, so the contrast of the image also decreased. So now this is the original image we have, and it is not scratched. Therefore the contrast is less. So automatically remember that when we are adding an image to the Erdas imaging, it is increasing the contrast of the image to better visual quality. So there are several other stretching methods as well. To see that, we can move into raster, panchromatic, and under the adjust radiometry. So here you will be able to see the different standard stretching methods. Equal percentage, left right percentage, the standard deviation stretch, min max stretch, linear stretch, Gaussian stretch, histogram equalization, level slice, and invert. Likewise the different stretching methods. So again, if you need to see further about these stretching methods, So you can go into general contrasting here, and you will be able to see the different methods of stretching are in here, like this. So first of all, let's select the standard deviation method, and let's change this standard deviation into 1. And then by applying that, you will be able to see this contrast of the image is changing. So likewise, you can try these different stretching methods, and I will take another one, so which is known as linear stretch. So linear stretch is showing the original image without any stretch. So the same color you will be able to see, this is the original stretch, and here we can open our breakpoints window again to see this stretching. So there's another method to open this breakpoint window, that is go to the content and right click on your image. Then here you will be able to see an option called breakpoints, and that will show you the histogram of this image. So this is linear stretch, so the original histogram is here, there are no changes like this, right? And then if we change this into standard deviation and then apply, so we'll be able to see that by applying this one as well, the image has changed as well as the histogram also changed. So in here, these breakpoints also changed. And if we change again this standard deviation into 2, let's apply and see, then you will be able to see that the histogram again changed rather than 1. Also by applying that, you can see the changes are happening to the image as well. So remember, the first you need to check with the standard deviation, and then you can go into the linear method of stretching like this. So the linear method is not stretch, it is showing the original image, and there are other methods as well. So check how these methods are working with the breakpoints also. So if we move into the histogram equalization, so that is another option that we are using to increase the contrast of the image. So these stretching methods you will learn during your theory classes, as well as try to understand how in these each methods the histogram is changed by stretching these values. So in here, this is the histogram equalization, and you will be able to see that in histogram equalization there are more points, so all these points have dragged into the equal proportion of the satellite image, like this. And the contrast of the satellite image has already increased. You can see this is applying for the color composite images as well. So I'm taking another view to here, going to add views, create 2D view, and then I'm opening the next image in that 2D view. So that is minute area 072800 image. it is a color composite image like this. And then again, if you need to see the breakpoints of this image, what you can do is you can select the view and then you can go into the content and right click on your image, then go to breakpoints, and in here you will be able to see that there are 3 histograms for the different colors, because this has different colors with RGB with the color composite. Also, these histograms again stretched like this. To see that, you can click on this LUT icon in here. So this is how the red color has changed, stretched. So the minimum 43 go to 0 and 142 go to 255. Let's see how green color has changed. So in green color, you'll be able to see that minimum is 33 and it has gone to 0, and maximum 88 goes to 255. Then let's see about the blue color one. Blue color also the same. They are showing different amounts of stretch. And now let's see how these things are working when you are changing these stretching methods. So again, what you can do is you can go now into multispectral under the raster. Then in multispectral, go to adjust radiometry, and then see the different methods that you can practice and check with the stretching, or just go to the general contrast in here, and then so here the first one is standard deviation method, so I'm going to apply that, and I'm moving to the breakpoints of this satellite image. Like this. Then I'm changing the method into linear method, and now you can see that the stretching has directly connected with the original histogram, and if you apply that one for each, so this is the original image, or you can just click this one, apply to all, then it will already applied. Then likewise check how the different methods are working in this satellite image with the color composite as well. So I'm going to select finally the histogram equalization, and again you will be able to see that these histograms are slightly equalized, so they are showing the same shape, and here the different red, green and blue ones are equalized rather than our standard deviation or min-max stretch, or the linear stretch. And by applying these type of stretching methods, we can increase the contrast of the image, as well as we can acquire different type of land use types from the satellite image easily. So as an example, let's see how to extract water bodies from a satellite image easily by using these breakpoints. So I'm going to close the color composite one, and I told you that this is near infrared image. So mainly water bodies are absorbing near infrared. So near to the water bodies, the contrast or the DN value of the satellite image or the pixels are really less. So therefore, by changing these breakpoints manually into a lower value like this, so first of all, let's select our original image by selecting the panchromatic and linear stretch. So this is the original image. Then let's see how to extract these water bodies. So what I'm going to do is I'm going to breakpoint, then I'm clicking on LUT icon, and under this gray I'm going to change the maximum point into 50 like this, Y as well as into 50. Then I'm closing that and I apply it. Then in here, these are the locations where we can see these high absorption or the low amount of reflectance. So the meaning is these are slightly like the water bodies. So let's check if I minimize this point into 40 and 40. Is this will reflect my image or my water bodies clearly or not? So still it is representing, but the clearance is somehow less. However, I can see the water bodies of the satellite image. So likewise, these breakpoints are really important to identify as well as to find out the different features on the Earth according to their DN values. However, remember that these images are not permanently changing like this, so they are temporarily changing during our work until we save them.